Hello, so in this video, I'm going to discuss my answers in the second exam of mathematics in the middle world. But before that, let me introduce myself. I am Apple May M. Arellano, a first-year civil engineering student major in structural. So let's start the discussion. Number 1. The Brunswick Research Organization surveyed 50 randomly selected individuals and asked them to the primary way they received the daily news. Their choices were via newspaper, represented by N, television, represented by T, radio, represented by R, or internet, represented by I. In this question, we are asked to construct a graph, any of the graph for the data, and interpret the result. So the data are given and we have to tally it in order to graph. So in television, we have 16 individuals. In newspaper, we have 10. In radio, we have 12. And in internet, we have also 12. So I use bar graph because I think it's the easiest one. So in the x-axis, I labeled it for the choices of how they receive the daily news, and in the y-axis is the numbers. So as we can see in the bar graph, the newspaper has the least number of individuals who uses it as their primary way to receive daily news. Both radio and internet had the same number of individuals utilizing it. Television has the highest number of individuals who uses it to receive daily news. Let's proceed to number 2. The net worth in billion of dollars of a sample of the richest people in the United States is shown. Find the mean, median, and mode for the data. So the given data is 59, 52, 28, 26, 19, 19, 18, 17, 17, 17. So in order to find the mean, we have the solution, summation of x I over n. So you have to add all the given data, then divide it by 10. So 59 plus 52 plus 28 plus 26 plus 19 plus 19 plus 18 plus 17 plus 17 and plus 17 divided by 10. So 272 divided by 10 is 27.2. So therefore, the mean of the net worth in $1 million of a sample of the richest people in the United States is 27.2. To find the median, we have to get the middle numbers of the given data. And since the given data is in even, we have to add the two middle numbers, which is 19 and 19. So 19 plus 19 equals to 38 divided by 2 equals 19. In mode, we have to find the most frequent numbers, and as we can see, 17 has the most frequent number. So therefore, our mode is 17. Let's proceed to number 3. So number 3, starting teacher's salary in equivalent US dollars for upper secondary education in selected countries are listed below. Which set of data is more variable? The US average starting salary at this time was $29,641. So in Europe, we have Sweden with a salary of $48,704, Germany $41,441, Spain $32,679, Finland $32,136, Denmark $30,384, Netherlands $29,326, and Scotland $27,789. In Asia, we have Korea, which have a salary of $26,852, Japan $23,493, India, $18,247. Malaysia, $13,647. Philippines, $9,857. And Thailand, $5,862. So, in order to find the most variable data, we have to put it in a table and compute the following data. In order to determine which data is more variable, we have to solve it. So first, we have Europe. In this portion of the table, we have to find the x minus mean and the x minus mean squared. So, in order to find the x minus mean, we have to determine the mean first. We have to add all this data and divide it by 7. So, the summation of Europe is 242,459 and divided by 7 is equal, the mean is 34,637. This 34,637, we have to subtract it on the value of in Europe individually. So this is the value of x minus mean that we have subtracted from here and the mean. And the x minus mean squared is these are the values. We only just have to square this portion, each of these portion in order to determine this one. So the summation of x minus mean squared is 347,453,504. So in this case, we can now solve the standard deviation, which is so in this portion, we can now solve for the variance. Variance is denoted as s squared, which is the summation of x minus mu squared divided by n minus 1. So since we already get the summation of x minus mean squared, we have to substitute it. 347,453,504 over our n, which is 7, minus 1. So 347,453,504 divided by 6 is 57,908,917.33. In this case, we can now find the standard deviation denoted as s, which is the square root of the variance. So the square root of 57,908,917.33 is 7,609.79. So the range is highest value minus lowest value, and in Europe, our highest value is $48,704. So, and our lowest value is $27,798. So $48,704 minus $27,789 is equals to $20,915. And in Asia, same as how we get in Europe in the distribution table, we have to find the mean in order to get x minus mean, and then every value of the x minus mean, we have to square it to get the x minus mean squared. So here the summation of x minus, the mean is 16,326.33, and the summation of x minus mean squared is 324,373,103.3. So in that case, we can now find the variance. So variance is the summation of x minus mean squared divided by n minus 1. So our summation of x minus Mean squared is 324,373,103.3 divided by n, which is 6 minus 1. So 324,373,103.3 divided by 5 is 64,874,620.66. And in that case, we can now find the standard deviation, which is the square root of the variance. Square root of 64,874,620.66 is equal to 8,054.48. So in that case, we can use a table. Here we can see to determine the more variable among Europe and Asia, we have to find its coefficient of variance. So as we can see here, the coefficient of variance of Europe is 21.91% and Asia is 49.33%. Since the coefficient of variation is larger for Asia, it is more variable than Europe. So let's proceed to number 4. Which has a better relative position, a score of 75 on a statistics test with a mean of 60 and a standard deviation of 10, or a score of 36 on an accounting test with a mean of 30 and a variance of 16? Justify your answer. So first, we have to find the z-scores for the statistics, and the z-score is x minus mean divided by standard deviation, and 75 minus 60 divided by 10 is 1.5. For accounting, you have the variance of square root of standard deviation. So the square root of 16 is equals to 4. So the z-score is also 1.5. Since the z-score of calculus and accounting tests are the same, the relative position is the same. Let's proceed to number 5. The data represent the values in billions of dollars of the damage of hurricanes. 1.1, 1.7, 1.9, 2.1, 2.2, 2.5, 3.3, 6.2, 6.8, and 20.3. What is percentile rank of 20.3? So the percentile, in order to get the percentile, we have the formula. Percentile equals to the number of values below x plus 0.5 divided by total numbers of values times 100. So percentile 2.3 is the have 9 values below it, plus 0.5 is 9.5 divided by 9.5 divided by 10 is 0.95 times 100 is 95%. So 20.3 is in the 95th percentile. What value corresponds to the 40th percentile? So C is equals to n times p over 100. So n is the number of values and p is the percentiles divided by 100. So 10 times 40 is 400 divided by 100 is 4. So 2.1 plus in 2.2 divided by 2 is 2.15. Hence, 2.15 corresponds to the 40th percentile. Anyone scoring 2.15 would have done better than 40% of the class. So, number 6. The average height of a certain group of people is 53 inches. The standard deviation is 4 inches. If the variable is normally distributed, find the probability that the selected individual's height will be. So, we have to find greater than 59 inches. We have to put it in a normal distribution. So, our mean is 53 and we have to find what is greater than 59 inches. So, in this portion, we have 59. So, the z-score is x minus mu divided by standard deviation, which is 59 minus 53 divided by 4 is 1.5. Hence, 59 is 1.5 of standard deviation above the mean. So here it will look, what will look like in the normal distributions is we have to change our mean to 0 and the 59 inches into 1.5. The area under the standard normal curve to the left of z is equals to 1.5 is 0.9332. Therefore, 0.9332 or 93.32% of individuals have the height greater than 59 inches. Next is letter B, less than 45 inches. So, same on letter A, we have to put it in a normal distribution, and since 53 is the mean and we have to find the 45, this less than 45 inches. So the z-score of 45 inches is -2. Hence, -2 of a standard deviation below the mean. So this is what it looks like in a normal distribution. So the area under the standard normal curve right of z is equals to -2 is 0.0228. Therefore, 0.0228 or 2.28% of individuals have height less than 45 inches. So, we're going to proceed on number 7. The number 7, and the question is, or what we have to do is to determine the correlation of the given question. An educator wants to see how the numbers of absences for a student in her class affects the student's final grade. The data obtained from a sample are shown. So, the number of absence denoted by X is 10, 12, 2, 0, 8, and 5. The final grade denoted by Y is 70, 65, 96, 94, 75, 82. So, letter A is we have to draw a scatter plot. As you can see, on the x-axis, we have the number of absence, and on the y-axis, we have the final grade. So, first is 0. So, here in the given data, 0 is the number of absence. So, its corresponding grade is 94. So, it should be right here. Next is 2. The corresponding grade is 96. Somewhere here. As follows by 4. It's 5. 5 and 82. Next is 8 and 75. 10, 70, and 12, 65. So, since we have already drawn a scatter plot, we should proceed to computing the correlation coefficient. So, in computing correlation coefficient, we have to put it in a table. So, we have 6 students. So, every student corresponds on the number of absences, which is the X, and their corresponding final grade. So, in order to find the XY, we have to multiply X, the values of X and Y in every student. Then, next is we have to square the X and the Y. So, summation of X is 37 and summation of Y is 482. The summation of X times Y is 2,682. The summation of X squared is 337. And the summation of Y squared is 39,526. Next is we have to find the correlation coefficient with a formula of n times the summation of xy minus summation of x times summation of y over the square root of the quantity of n times summation of x squared minus the summation of x squared times the quantity of n times summation of y squared minus summation of y squared. So we have to substitute all the given values from our table, and we have the n is 6, so our total, the number of student is 6. So 6 times the summation of xy, which is 2,682, minus summation of x, 37, times the summation of y, 482, divided by the square root of the quantity of 6 times the summation of x squared, which is 337, minus the summation of x, 37 squared, times the summation, the quantity of 6 times the summation of y squared, which is 39,526, minus summation of y, 482 squared. So our correlation coefficient is negative 0.981. So therefore, the linear correlation coefficient for the data is negative 0.987. So next, we have to test the significance of the correlation coefficient at alpha, which is 0.05. So our HO is P is equal to 0, and our H1 is, our null hypothesis is P not equal to 0. So n minus 2, where n is 6 minus 4, then the critical values is at positive negative 2.776. So our T is equals to the linear correlation coefficient times the square root of n minus 2 over 1 minus r squared. So our r is negative 0.981 times the square root of 6 minus 2 over 1 minus negative 0.981 squared. So 0.981, it has 1 here, times the square root of 4 over 1 minus negative 0.981 squared. So our T is negative 10.11. The significance of the value found in part B is that the value of R is negative 0.981, implying that there is a strong negative linear relationship between the two variables, number of absences and final grade. So next is we have to determine the regression line. So in A, we have a formula, summation of y times summation of x squared minus summation of x times summation of xy over n times the summation of x squared minus the summation of x squared. So in A, we have to substitute all the values. 482 times 337 minus 37 times 2,682 divided by 6 times 337 minus 37 squared. So our A is equal to 96.78. Next is B. This formula in finding B is n times the summation of xy minus the summation of x times the summation of y over n times the summation of x squared minus the summation of x squared. So we have to substitute again all the values here. So say 6 times 2,682 minus 37 times 482 divided by 6 times 337 minus 37 squared. So the value of RB is negative 2.67. Hence, the equation for regression line is y equals to a plus bx. So y is equals to 96.78 plus negative, the quantity of negative 2.67x. So we have here our y is 96.78 minus 2.67x. To graph the line, select any 2 points for x and find the corresponding values for y. So, we have to let x sub 1 equals to 8 and x sub 2 is equals to 10. So, here first we have the 8. So, 96.78 minus 2.67 times 8. 2.67 times 8 is equal to 21.36. Then, 96.78 minus 21.36 is equal to 95.42. So, our first point is 8 and 75.42. Next, we have the 10 as our x. Then, negative 2.67 times 10 is negative 26.7. So, 96.78 minus 26.7 is equals to 70.1. So, our next point is 10.7, 10 and 70.1. So, since we have our points, we can now plot our another regression line equation and another scatter plot. So, in here, our 9, which is 96.78 minus 2.67x, wherein our x is corresponds to 10. So, this is what it look like. So, lastly, we have to interpret our results. So, this data is quantitative data due to the fact that this is measured by numbers. The linear correlation coefficient of the data falls on being or having a strong negative relationship between the two variables. Therefore, we can conclude that the number of absences of the students can affect their grades. As I've noticed in the correlation, that the more a student have absences, the lower the grade, and if the fewer the absences, the higher the grade. That's all. Thank you.